Tom DeQuino, there. You are. I see you. Do I hear you?
Hey, Jorge. Yeah, I am here.
I hear you. Take it away.
Fantastic. Thank you for that. And thanks to everyone who's participating in this solution track for the SANS Threat Hunting Summit today. My name is Tom DeQuino. I'm going to be talking about automating threat detection validation with PowerShell Empire and /havoc. I'll give you a little bit of background about myself here to kick things off. So first off, I am a senior security engineer at Vectra AI. I'm also the lead developer of the open source /havoc platform that I'm going to be walking you through here today. I've got a 20-year background in information technology, almost exclusively in that time focused on cybersecurity disciplines. Really, at the end of the day, but like the first time I had an opportunity to sit in a SOC, track a live attack through an IDS console, I was hooked. I knew like this is my life's work, and I've been doing it ever since. So thrilled to be here presenting this with you guys today. I'm really excited about what you're going to see. Hopefully you love it as much as I do. And just a quick note on Vectra. Vectra enables enterprises to immediately detect and respond to cyber attacks across cloud, data center, IT, and IoT networks. We do that by leveraging a machine learning based platform with network sensors that inspect packets, convert those inspected packets into metadata, and then we apply a bunch of different machine learning algorithms on top of those packets to be able to detect malicious or adversary oriented traffic on the wire. And that's one of the reasons I'm kind of here talking about this today. It's something that I have a bit of a preoccupation with is, how effectively can our network security stack that we have deployed in the environment actually detect some kind of malicious traffic on the wire. This is what I do day to day for our customers. And so I really want to make sure that what I'm putting in front of those customers is effective and does what we profess it should be able to do. But more than that, I just really want to be able to provide the community with something that they can use whatever tool set or security stack they happen to have deployed. There should be, in my opinion, a framework out there, a platform out there that's easily accessible that enables people to be able to test and validate their defenses. And so that's really what this is about today. So let's talk a little bit about what threat detection validation is. So it's kind of two sides of the same coin between pen testing and threat detection validation. There's a similar approach, a little bit different perspective applied to it though. Penetration testing is typically objective focused. So you're often asking questions like, can the network be breached? Can privileges be elevated? Can sensitive data be extracted from the environment, right? And the other, significant detail about penetration testing is that it's selective and infrequent, right? So it's typically very pointed. You're looking for specific ways into the environment. It's kind of, get in by any means necessary, but once you find a path that you think is going to bear fruit, then you really kind of focus in on that and follow it through to fruition, and hopefully, establish that, that weakness, whatever it happens to be, allowed you in, you're able to elevate your privileges, et cetera, right? Threat detection validation is more operations focused. So you're asking questions like, are security devices functioning as expected? Which TTPs trigger detections? Which detections do they trigger? And how do we front threat hunt for similar TTPs? So this is, I think, significant in that you're answering questions from kind of two different directions. One is just, is our environment operational day to day, right? So you're literally doing this kind of, you can run this kind of stuff on a daily basis, right? That's the kind of the idea behind threat detection validation is, let's put traffic on the wire every single day and make sure that we can detect it. Make sure that our span ports are still configured, make sure that our IPS rule sets are in place, and that the assignment of the rules is applied so that the evaluation actually takes place. There's just all kinds of things that can go wrong with a complex architecture and security stack. So you need to be validating it on an ongoing basis. And that's really what this is about. And then, to extend that, if you're trying to figure out, well, which TTPs can we actually detect? What does it look like when we detect them? Then it's really critical that this type of testing is exhaustive, right? So you're not just trying to find, well, what's the, couple of ways we can get into the environment. It's more so like, let's put as much stuff onto the wire as we possibly can and make sure that we can identify these things as they're going on, and that we have appropriate visibility into them. Okay, so it's exhaustive and continuous. All right, moving on to the next slide here. So what is PowerShell Empire? I mentioned this is automating threat detection validation with PowerShell Empire and /havoc. Well, PowerShell Empire is an open source, pure PowerShell post-exploitation command and control agent. It has a malleable C2 capability in it that's provides some adaptable communications to enable you to evade network detection. You can find out more if you're not already familiar with it at PowerShellEmpire.com. And there is a fork of the original PowerShell Empire that's maintained by a group called BC Security, and you can find their fork of PowerShell Empire in GitHub at github.com/bc-security/empire. And I'm mentioning that because the PowerShell Empire version that we're using in the /havoc framework is based on it's basically this fork that I'm pointing at here that we're going to be testing with today. It has a lot of different capabilities in it that we're really going to be able to leverage, and I'll talk about that a little bit more in a minute. What is /havoc? It's an open source cloud native attack automation and security validation platform. Basically enables you to automate the provisioning of attack infrastructure and execution of the security validation activities. So I was just talking about PowerShell Empire in the previous slide. Basically with the /havoc platform, you have the ability to spin up PowerShell Empire containers in AWS. And it's all API driven. So you make some simple API calls to the /havoc framework, and it will launch the PowerShell Empire containers for you, or whatever attack container you want to have. Right now, it's got a limited set of selections for attack containers. We're building it out, and hopefully it'll grow substantially here as I'm starting to show this platform to folks. It is all open source, so you can contribute to it. You can add your own custom containers to it if you want. But the cool thing about this is that it's all cloud-based infrastructure. You deploy the /havoc platform in your own AWS account. It's really inexpensive to run, and you're basically maintaining all of the testing validation within infrastructure that you control. You can find out more at the website here, havoc.sh. Okay, and so how do PowerShell Empire and /havoc help with threat detection validation? Well, I mentioned a minute ago that PowerShell Empire provides a malleable C2 channel, which basically enables you to employ tunneling techniques that emulate well-known threat actors, or to employ tunneling techniques that emulate benign services. So there's two different angles that you can take with this, one of which is hey, can we emulate well-known threat actors and make sure that we can detect those things? And then the other angle is how crafty can we get with our communications to evade the defenses that we have in place? How effective are our defenses at detecting those evasion techniques, right? So malleable C2 is a concept that many of you may be familiar with from Cobalt Strike. PowerShell Empire is free and open source, so it's kind of a poor engineer's version of Cobalt Strike. Maybe I happen to be a fan of it, though. I really like open source tools, and the fact that you can do this kind of stuff free without any significant investment is really, really beneficial, I think, for the community. Okay, and in terms of how Havoc helps, basically we provide pre-built attack containers and an API to make it easy for you to quickly provision the PowerShell Empire container and all the supporting infrastructure. You're able to automatically iterate through testing multiple tunneling techniques just by sending commands to the container via the API, and all of the infrastructure, everything you need is kind of just deployed and set up for you really, really easily. I need to pick up the pace here and make sure we can get everything illustrated here for you. So apologize if I start going a little bit fast, but I got a lot to show. So the demo architecture, I'm actually going to do a live demo of these two platforms working together, PowerShell Empire and /Havoc. And this is the demo environment that we're working with. Basically, we have in AWS, a /Havoc deployment, which is going to have a PowerShell Empire container, an HTTP server, a web server container, a shared workspace between them, and basically we're going to launch. In fact, there's going to be multiple PowerShell Empire containers. We set up listeners on them that will enable us to establish multiple command and control tunnels. And those listeners, in order to establish those tunnels, you have to generate agents, which need to be sent down to the testing host and executed. And so we're going to share those agents in our shared workspace here so that they can be downloaded from an HTTP server. And the testing host is going to go pull those agents down from the testing server or from the HTTP server, and then the testing host will execute them and establish a tunnel back to PowerShell Empire, the various containers. Now we have a Suricata IDS instance sitting inline, or rather like Lollipop on a stick here, like monitoring the traffic going out, and all the logs that are being generated by it are going into an ELK instance. I saw a question here that asked, is it Amazon, just Amazon or just AWS and not Azure? At the moment, it's fully AWS, Amazon AWS based. I haven't ported all the code infrastructure over to Azure. One thing that I think is really significant about this is it's 100% serverless. So all the containers run inside of Amazon's Elastic Container Service. The shared workspace operates through S3. All the interaction that you do with the containers is happening through Amazon's API gateway. So this is a really, really cost-effective platform because it's not running servers all the time, right? It's just, infrastructure, like on-demand infrastructure kind of deployment. But because of that, it's very tightly wound into AWS resources, and I'd have to re-architect the whole thing to build it around GCP or Azure. Maybe at some point we'll get to that, but for right now, I'm just working with AWS. Okay, so agent downloads are going to happen from the HTTP server. The CT tunnels are going to go to the PowerShell Empire attack containers. And this is the testing sequence that we're going to go through. We're going to basically spin up 3 different containers, one of which is 3 different PowerShell Empire containers. And each one is going to run its own listener. We're going to have one that emulates an APT profile called Sophisy. We're going to have another one that emulates a crimeware profile called Emotet. And we're going to have another one that emulates a benign Windows update traffic to try to, obscure the tunnel's presence and hide the activity. So we're going to initialize those containers and the listeners on them. Then we're going to generate a PowerShell Empire launcher. We're going to transfer that launcher to the HTTP server. We're going to download it to our test host. And then we're going to execute it and establish a tunnel. And then we're just going to run a command through the tunnel just to put some traffic on the wire. And then we'll kill the agent and basically go through that same sequence for each of these. I will say that the playbook that I built for this is brand new, and I'm having a little bit of trouble with the Emotet bit, so it may not work, but at least we'll be able to see Sophisy and the Windows update traffic on the wire. And I'll show you what that looks like in ELK so that you can see how Suricata detected it, et cetera. And I should also mention, I'm just using the open source emerging threats rule base for Suricata, so nothing especially advanced there in terms of its detection capabilities, right? Okay, and with that, it's demo time. So let me go ahead and share my screen here. Jorge, can you let me flip over so that I can share my own desktop?
Yes, I believe Ashley or Dustin can give you
Or
that
Dustin?
access.
All
There you
right.
go.
You were already sharing, but I stopped it so you can just share your new screen if you want.
Fantastic. Okay, here we go. So you should be seeing a dark blue command line window, right? Okay, thank you for that, just for confirming. So I'm going to do a couple of things here. First thing I'm going to do is run a playbook that I'll walk you through basically what's happening. Apologize for the command line interface, but the Havoc platform is all API based. There is no UI associated with this. So you're basically just executing playbooks that go out and perform the tasks at hand and generate the traffic on the wire. And the intent behind this is to make it easy to be able to automate these things. So you can run these as, you can put this container inside, or this playbook inside of a container, and just execute the container periodically, once a day. Same thing with the testing host that's inside the network that's being monitored. Just run it periodically as an automated container task of some sort. So that's really what we're going to go through here today. I'm just going to kick off the playbook. It's called playbook.py, and I'll walk you through what's happening. Basically, we are launching an HTTP server task with a unique task name. And keep in mind, this is actually the first time I've ever presented this in public, which I'm really proud to say that I'm here to be able to do this. It's quite a Herculean effort in order to get all of this stuff together. So super excited about it, but bear with me. It may have some bumps in the road. This playbook is not perfect. So we'll see how it goes. Now that we've got our HTTP server task launched, we're launching a PowerShell Empire task for the Sophisy listener, one for the Emotet listener. And actually, I've been having some issues getting the stager to generate for this Emotet listener, so we may not have that work for us here today. But at the very least, if we get Sophisy and Windows Update, we'll still be able to see a good amount of traffic on the wire and be able to dig into that. Okay, so we're launching four separate containers here. And once these are up, we're actually going to monitor the container status to make sure that the container is ready for us to start interfacing with it. And so it's coming back now and saying, hey, we've got HTTP server ready, so we can start interfacing with that. And now we're going to wait for the Sophisy, Emotet, and Windows Updates containers to become available so that we can start issuing commands to these things. And while that's happening, I'll also mention, we're just executing the agents on our test network, intentionally, right? And you might say, well, that's kind of cheating, right? Like, how did the malicious agent get into the environment in the first place? And in this instance, we kind of don't care about that. What I'm asking you to do here really is to just hit the I believe button. Like, at some point, an adversary is going to get into the environment. If they're determined enough, they're going to find a way in. And the question then becomes, can we detect it when they're in the environment? And that's really what we're kind of focusing on here today is, when the traffic is on the wire, are we going to spot it, right? And can we put a good representative bit of traffic on the wire in order to demonstrate that we have really strong detective ability? Actually, this is going to take a minute, so I'm just going to shift gears here for a quick second and show you just a couple of things. First off, installing the /havoc platform, really, really simple. If you go to havoc.sh, there's a link to the docs here. The install is pretty much just Terraform init, Terraform plan, Terraform apply. You got to set up a couple of parameters, which are all detailed in this documentation, but it takes literally 3 minutes, maybe 4 minutes to deploy the entire platform into your AWS account. So really straightforward to get going. Once you've got it in place, you can start taking advantage of these PowerShell Empire attack containers. There's a Metasploit attack container, an Nmap attack container. So there's all kinds of different things that you can utilize there. And each time you spin up a new container, it's actually going to get a unique IP address, right? So here we go. We've got our Windows updates is ready. So you can see like each one of these systems is going to have its own IP address. You take down the container, fire it up again, it'll get a new IP. So it's pretty trivial to switch around your IPs for your infrastructure. You can change, assign host names to like fully qualified domain names to the attack containers. So what we're doing here is we're just setting up an SSL certificate is what we did here. We created an SSL certificate on our HTTP server, and then we started the web server using the certificate. And now we're creating listeners. So on the Sophisy container, we're creating a Sophisy listener. On the Emotet container, we're creating an Emotet listener. On our Windows Update container, we're creating a Windows Update listener. And each one of those is basically just the command and control server that's going to be interacted with through the tunnel. And now we're generating a stager, which is the agent that you're going to execute on the endpoint in order to establish the tunnel. And since we generated the stager, then we upload it to the infrastructure so that it can be shared with the HTTP server. And so right now we're telling the HTTP server, hey, go ahead and sync your local workspace with the shared workspace so that we can get that agent available to be downloaded. And now it's at the point where it's just waiting for an agent connection to take place so that it can run through the further sequence of putting activity on the wire, right? So I'm going to go over to this container that I have running on our test host, and I'm going to run a little utility here called TrainMan. I don't know if for folks that are familiar with the Matrix, this is a little homage to the Matrix. There was a guy in one of the Matrix movies that it was the train man. He worked in the subway and like shuttled people around the underground of the Matrix or between the real world and the Matrix. And he's kind of a gritty dude that is a little odd, right? And this utility is sort of a little bit gritty, and moving malicious files into the environment intentionally is a little bit gritty. So there we go. We called it Train Man. All right, so it's getting a stager to execute. It's pulling down the Sophisy stager basically and executing it. And as soon as it did that, the agent status monitor told us, hey, we've got an agent connected that we can start interacting with. So we sent a command, just a simple ls command to the agent to just put some traffic on the wire, right? And now we're waiting for the results of that command to come back. And this is happening through a tunnel where it's often the case that the adversaries, they're trying to obscure their behavior in the environment. So they might have really slow tunnels to try to make it look like just regular old HTTP traffic. So it took a little while for that to come back because of the beaconing behavior associated with the tunnel. So now that we have that, we're going to kill that agent and wait for a new one. And if we shift back over here, this guy is gonna, as soon as that agent dies, go ahead and run the next executable. Let's see, looks like it did that. Okay. So we're generating another stager to push up to the HTTP server. So this is the Windows Update stager. And there we go. So the train man just downloaded the latest Windows update stager and is executing that. And our agent status monitor has come back in and shown that, okay, we've got a new Windows update agent that's connected, and executed a command through it, waiting for the command results to come back. Okay, and so I'm just showing 3 examples here, Sophisy, Emotet, Windows updates, but there are a lot of different malleable C2 profiles available in PowerShell Empire for you to be able to test. And of course, you can create your own profiles as well. So hopefully, one of the things that's great about this being open source, as more threat actors are identified, the tactics or the tools that they're using are identified, hopefully we'll continue to see more malleable C2 profiles come out that emulate those tunneling profiles, so that we can then, continue testing and really make this an exhaustive exercise, right? So there's probably 30 different profiles right now that we could test with. I'm just testing with 3, but that's kind of the point of automating this, to be able to manually put all of those different profiles on your wire and see if you can detect them would just take forever. Doing this in an automated fashion with a ./havoc framework and PowerShell Empire, just fully automated in AWS for you. You can spin up a ton of different containers. You can put all this different traffic on the wire, and you'll get this entire test sequence done of maybe 30 or 40 different profiles in an hour, or maybe 2 hours. If it takes 3 hours, who cares? It's off running in the background in an automated fashion, and you don't have to sit here and babysit it. Okay, so that is basically it. The system is done, and so we drop back down to a prompt because a playbook ran through to completion. And I'm just going to jump over here and show you real quick. These are some of the malleable C2 profiles that you have at your disposal. If I drill down into the APT category, you'll be able to see here that there's a pretty good list, right? Sophisy is the one that I pulled out of here, but there's a handful of other profiles that are APT related here. If we go into the one that's really scary, actually, is the normal profile. There's a good collection in crimeware as well, but if we drill down into normal, this is the scary stuff. These are the evasion techniques that adversaries are able to use, and this is a pretty long list, right? I picked Windows updates out of this, but gosh, I mean, if you want your tunnel traffic to look like Pandora or Office 365 calendar traffic, you can do that with these malleable profiles. And this is all stuff that's available in Cobalt Strike, which has been being seen more and more as the beacon or tunnel of choice for advanced adversaries out there, because they can do this kind of stuff, right? And so that's really kind of the concern here, is like, okay, if they're doing this, we need to make sure that we can detect this kind of thing, right? So let's go ahead and actually let me jump back here for a quick sec, and I'm going to grab some IP addresses. So let's grab the Windows updates IP address here. Actually, let's start with Sophisy here, and we'll just go take a look at that traffic first. There it is. So this is our Sophisy task. I'm going to grab the IP associated with that, and we'll just do a quick search here. Let's see if we've got some traffic associated with this. There, it's going, I promise. I'll just show this really briefly, and then I'll wrap up for questions. Come on. Elasticsearch is having a little bit of trouble here, but there we go. All right, so we saw lots of HTTP traffic in the environment, right? So a lot of flow data coming through here. There are a couple of alerts, some file info detections. If we drill down into this alert. This is the thing that likely a SOC is going to see first. So what does this alert look like? And it's basically saying, hey, we got some targeted malicious activity that was detected. It identified as some type of malware, some details about the host information in the environment, the URLs involved, et cetera, right? So there's a decent detection that came off of this. Also, this file info information and a lot of HTTP data that we can drill down into to really get a sense of, well, what is this? What is the pattern of this activity look like? What are the URLs involved, et cetera? And if we come back in, and I promise I'll wrap up after this. Let's grab the IP address for the Windows update, because I think this is really interesting. This one is much less likely to generate any kind of detection alert. I mean, there might be something, but it's much more likely to maybe trigger some kind of an anomaly alert, maybe some unusual behavior type of alert, but not necessarily just a flat out, hey, this is malicious kind of alert. So if we dig through this here, we see lots of flow data, and actually that is it. Oh, I grabbed the wrong IP. I apologize. That was for the HTTP server. Here we go. Let's grab Windows update. All right, here we go. And I guess, Jorge, while I'm pulling this up, probably a good time now if you want to go ahead and dive into questions.
Awesome. No, this was awesome. I love the demo. I'm also a fan of Empire. Got a little scared back in 2019 when they said they weren't gonna do it anymore, because it's the C2 we use in Security 564, the Red Team exercise and adversary emulation course. And yeah, we love open source stuff. Also, it's consistent, which is important as well with C2. So really cool tool that you have released here. I like that it's serverless and allows you to test a whole bunch of profiles. And that's one of the things we say when we look at things like a lot of people try to detect particular C2 tools instead of the actual behavior. And here you're actually going after the behavior, that communication, right? And I'm guessing this info here, I mean, how does all this tie back to Vectra?
Yeah, thank you for bringing that up, because this is really one of the things that that we're hyper focused on, is being able to identify this type of tunneling activity. I mean, we do lots of other types of detections as well, but we're really, really adept at identifying this type of tunneling activity because we're not signature based. And as you can see here, the best we got out of that Windows update profile were just some anomaly detections here. And it's not necessarily saying like this is bad. It's just basically flagging it as like, hey, there's something about this that's maybe a little bit off. There's an abnormal CE header is what it triggered on. And it's saying it looks like this looks like Windows update traffic, right? And so being able to rely on signature-based tools to detect this kind of stuff is a bit dodgy, right? I mean, I love Suricata. It's a fantastic platform. Zeek, Bro IDS, all of those tools out there are really, really cool for monitoring infrastructure. But at the end of the day, you're going to have a really, really hard time detecting tunnels like this using signature-based tools. And then the other thing is I'm doing this in clear text, right? If I wrap this in an SSL certificate and encrypted the session, it's game over, right? You pretty much, unless you're doing SSL decryption everywhere, your signature-based tools, your IPS, kinds of platforms are going to be really, really hard pressed to even detect this, let alone prevent it from happening in the environment. And Vectra, because of how we've built our machine learning algorithms, we're especially adept at being able to identify these types of tunnels on the wire. Even if they're going through encrypted sessions, we can still tell that it's tunneling or beaconing behavior without having to do any decryption. It's all behavioral based. as opposed to relying on signatures to identify what may or may not be a tunnel. And so that's really one of my key interests in this is, being able to put the Vectra platform through the ringer, throw all of these different profiles at it, make sure we can detect all of them and the adversarial behavior that's going through them, right? So
Yeah,
and
awesome.
I think I've
No,
used
thank
up all
you.
my time here. So
Yeah, no, thank you so much, Tom, for this.